If I asked you, what's point 1 plus point 2, you'd say point 3, right? But ask a computer, and it might surprise you. In almost every programming language, this simple addition gives you 0.3, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 4. No, your computer isn't broken. Let me explain why this happens. This weird result appears in Python, JavaScript, Java, basically any language you can think of. It's not a bug. It's actually working exactly as designed. The issue? Computers and humans speak different mathematical languages. We use decimal, base 10. Computers use binary, base 2. And just like some words can't be perfectly translated between human languages, some numbers can't be perfectly translated between decimal and binary. Here's a simple way to think about it. Imagine trying to represent 1/3 as a decimal. You get 0.333333 repeating forever, right? You can never write the exact value. You'd need infinite digits. The same thing happens when computers try to store 0.1 in binary. In our decimal world, 0.1 looks simple, but in binary, it becomes an infinitely repeating pattern, like 0.00110, 0110, going on forever. But here's the catch. Computers don't have infinite memory. They have to cut off these repeating digits somewhere, usually after 53 binary digits for a standard number. When your computer stores 0.1, it actually stores something like 0.1 followed by 15 zeros and then 555, just slightly more than 0.1. Same with 0.2. It becomes 0.2 followed by 16 zeros and then 111. Add these tiny errors together, and instead of getting exactly 0.3, you get 0.3 followed by 16 zeros and then a 4. The error is incredibly small. We're talking about the 17th decimal place, but it's there. Now you might think, who cares about such a tiny error? Well, these tiny errors can have huge consequences. In 1991, during the Gulf War, a Patriot-missile failed to intercept an incoming missile because of accumulated floating point errors in its timing system. The error had built up over 100 hours of operation, causing the system to look for the enemy missile in the wrong part of the sky. 28 soldiers lost their lives. Even in everyday programming, if you write code like if 0.1 plus 0.2 equals 0.3, it will return false, potentially breaking your entire program logic. So how do we handle this? For most calculations, we don't check if numbers are exactly equal. Instead, we check if they're close enough, within a tiny tolerance. For financial applications dealing with money, many systems avoid decimals entirely. They store everything in cents as whole numbers. So 1999 becomes 1,999 cents. No decimals, no problem. So remember, when you see 0.1 plus 0.2 giving you that weird result, your computer isn't glitching. It's just speaking binary while trying to express decimal thoughts. Understanding this helps you write better, more reliable code and appreciate the hidden complexity in even the simplest calculations. What other weird programming behaviors have you encountered? Let me know in the comments below.